Hey, what's up, guys? This is Chung here. So this time, let's take a look at today's daily challenge problem number 785. It's graph bipartite. So you're given like an undirected graph. Return true if and only if it is bipartite. So a graph is a bipartite if we can split its set of nodes, right, into two independent subsets, group A and group B, such that every edge in the graph has one node in group A and one node in group B, right? And so the graph is given in the following form. So the graph I is a list of indexes j. Basically, the index represents the edges, right, for the current node, right? Basically, this one is index 0. 0 connects to 1 and 3. Okay. So, for example, right, we have these four nodes here, and we can split it into two groups. So either to two. So one of the split is going to be a 0 2 in one group and 1 3 in another. Basically, we have 0 and 2, and then we have 1 and 3. So now each edge, right? So for each edge, we have like the on one side is it's group A, and on the other side is group B. So same thing for all edges. That's why the answer is true. Okay. So but for this one, right? So the answer is false because there's no way there's going to be a conflict, which means that let's say no matter how we split these groups here, there are always going to be a conflict because of this diagonal edges here. Because let's say we try to put 0 into group A, right? And then basically we need to put 1 and 3 in group B, right? And then because since we need to follow the rules, right? So on each edge will connect two groups. So which means that assuming we have 0 in group A and then 1 3 in group B, so here we should have like either 0 group A or group B, but we have a conflict, right? So if we have 0, if we try to assign the group based on 1 here, so this one should be a group A, right? But this group A is basically it's conflict with this one because there's another edge here, right? So basically there's an edge that's connecting to the same group, which is why the answer is false. Okay, so yeah, actually, we have already found the solution, right? Basically, we just need to try to assign the groups one by one. Basically, it's a layer by layer, right? So, for example, if this one the group is A, right? And then for all the neighbors, right, the group has to be B. Okay, and then yeah, basically, so since A has 0 has 3 neighbors, if we assign all the neighbors to group B, then which means this one is already B. Okay, and then when we try to process node A here, right? Okay, we have seen that. Okay, so we have another node, right? So the node is basically has the neighbor has the same group as the current one, and then that's when we need to return false. Yeah, so basically that's gonna be our idea. So we're gonna basically assign the groups layer by layer, and until we have find a conflict, then we'll return false. And one more thing is that it didn't tell us very clearly is that the graph may not be connected altogether. So which means that we could have like multiple components of edges. So which means that we have to basically try out the nodes. Cool. So let's try to do the coding here, right? So so to make sure we have considered all all the nodes here, we can simply do this. The node in range of length of graph, right? Because the length of the graph represents the entire node. And yeah, let's just do another scene here. So we're gonna have like another dictionary to actually let's do a stat. Oh no, we need to yeah. So I'm going to use this scene dictionary to maintain both the the scene nodes and also the group for that node. Okay, right. So I mean here we can use like A or B, right? Or we can use 0 or 1. Okay. So the benefit of using 0 or 1 is that we can use like the XOR to easily assign the group based on the previous group. So okay, if node, right, not in scene, we'll start our our traverse, right? So it can be either like DFS or BFS, doesn't really matter, as long as we have traversed the entire graph. So here, the scene dot node equals to 0. So yeah, I'll just use 0 or 1 to represent those two groups. So now at the beginning, I assign this group to group 0, right? And then we add this one to the stack. And then while stack, right? So while stack, we have a current, gonna be the stack dot pop. Okay, and then for all the neighbors, in the graph of the current, right? So there are basically two scenarios here. So the neighbor could have already been assigned to a group or not, right? So first one, if the neighbor has not seen before, right, which means that it's going to be a new node, and then we can simply first we'll add this one, right? We'll add this one to the stack, right? And then we'll assign the color, right? So what's going to be the color? So it's going to be the different color comparing with the current one because it's neighbor. Basically, if it's A, I'll assign to B. If it's B, I'll assign to A. So similar for 0 or 1, right? So I'm going to assign this one to neighbor equals to the scene dot current do a XOR, right? Yeah, so that's how we flip the value for 0 or 1, right? And else, right? So else we can simply do a check. Basically, if the neighbor has already been seen before, and then that's when we need to check if we need to return false or not, right? Basically, if the scene dot neighbor is the same as the scene dot current, right? And then we know, okay, we have a conflict. That's when we need to return false. Otherwise, no, we just return true in the end. Cool. So if I run the code, accept it. Yep. So it passed, right? I mean, I think that's the the that's the logic, right? I mean, just to recap real quick, right? So the main idea here is that we just assign the groups, so each node to its like a corresponding group. So the rule is that since the edge will connect to we're always connecting to two groups. That's why when we assign the group, right? When of course when the neighbor has not been seen before, which means that this node has not been assigned to group yet, then we always flip the previously group values, and then we assign that value to the current one. And then if the current node has been seen before, then it's time for us to check if there's a conflict, right? So basically, if the group of the current one neighbor is the same, then we have a conflict, because edge always needs to connect to two groups, the nodes from two groups. And the very first for loop here is to handle that disjoint graph here, because we could have multiple components for this graph. That's why we need to make sure we traverse to all the nodes. And the scene is to help us to record the node we have been processed and the groups we have for each node, for each processed nodes. Yep. I think other than that, I think that's pretty much, I don't have anything I wanna talk about right now. So yeah, I hope you guys like it, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.